Hey there everyone, welcome to another video, and today we're gonna learn about some fundamentals of Rust that are necessary to understand or read any Rust program. So with that said, let's get started. So as you can see on my browser screen here, I have noted down few points that we will cover in this video today. So first one, we have variables and mutability. We will learn how to create a variable and what makes a variable mutable or immutable. Secondly, data types. Thirdly, functions. What are functions? How do we create them? How do we create a parameterized function? Their return types as well. And fourth and fifth, we have control flow and shadowing. We learn how if else statement works, a loop works, and what is a shadowing or variable shadowing, and how do we implement in Rust. So with that said, let's open our terminal. Let's head over to a directory and let's create our project. We will name it fundamentals. All right, so by the way, if you don't know what cargo is, so please check out my previous video where I have instructed how to install Rust in your local system and few points about cargo, that what is cargo and how do we use it in Rust project. So let's create our new project. So as you can see, the project has been created. Let's head over to a directory. Let's open it in our neovim. As you can see, we have a main file over here. For now, we will write all our implementation in main file. So let's head over to a browser and see what is the first point on the list. We have variables and mutability. So to declare a variable, we use let keyword followed by a variable name and an initial value at the time of declaration. So this is how you declare a variable in Rust. Let a equals 2. Now this variable a has automatically inferred its type as integer. So let me show you one more funny thing over here. So if I try to mutate this over here, let's say a equals 4. As you can see, I'm receiving an error that I cannot mutate an immutable variable. So this means that in Rust, whenever we declare a variable, it is immutable by default. So now the question is, how do we mutate a variable then if it's immutable by default? So we create a variable mutable by using a mute keyword. So you can see there is no error right now and we can now mutate the variable. So let me show you how do we test it. Introduce a print line statement over here. Let's say before value, right? A, and copy this, and we will also see what is the after value after mutating, right? Just change it to after. Save it, open the terminal, hit cargo run. As you can see, before it was 2 and after it was 4, as you can see on your screen. So this is how we declare a variable, and the key takeaway from this point is whenever we declare a variable, it is immutable by default and we make it mutable by using a mute keyword. All right, let's head over to the second point. Now it is in data types. So we are not going to cover data types in this video because it is like Rust provides very wide variety of data types, and definitely we will go in detail in the upcoming chapters. So for now, let me just tell you, data types in Rust are divided into two categories. One is scalar and one is compound. Now scalar is what all primitive data types are, like integer, boolean, float and all. And in compound we have array, tuples, string literals, strings. We have like user defined data types like struct and enums and all. So we will cover them in upcoming chapters in details, but let's now move to the third point, that is functions. To define a function in Rust, we use fn keyword. Okay, so let's say we want to define a function named add, so we will use fn add and this. So this is the syntax of a function in Rust. Now what if we want to create a parameterized function? So we will define parameters over here. Let's say x and y are the two parameters that this function takes. So as you can see, we have an error right now because in Rust, whenever we introduce parameters to a function, we need to also define their types. So to define types of a parameter, we use colon and we define the type. Let's say x is i32 and y is of type bool. As you see, now this function add takes two parameters of types integer and boolean. All right, so this is how you define parameters in a function. Now what if we want to define a return type as well? So to declare a return type, we use dash and arrow key, and we define the type as well of the returned value. So let's say this function will return an integer value, so we will use this function arrow and the type of the value that will be returned. So if I write over here return 2, then it's a perfectly valid statement over here. As you can see, in Rust, a return is defined in two ways. So first of all, this is like return value and semicolon, right? But another way is you don't need to define return and don't need to define semicolon, you simply write 2 over here. Let me just comment this. So this is also a perfectly valid statement over here, that this function a add will return 2. All right, so let me just call this. So let's say let result add. Now we will have to pass this like 2 comma true. All right, let's introduce a println over here. So let's run the project, save it, open terminal, cargo run. So as you can see, we have few warnings over here, so we can like currently ignore them, and we see here that before value 2, after value 4, and this is the value that our function has returned, right? So it's 2. Let me exit this now. So now that you have learned that how to write a function, how to define a function, how to introduce parameters to a function and return types to a function, let's move ahead to the fourth point. So we have control flow. Now in this point we will learn how if else conditions or statements work and how loops works in Rust, right? So let me introduce you how if else and loops work in these functions only, right? So let's create a logic over here. Let's see, we want this function to return a value, but first check if y is true or not. So as you know, if y equals true, and there is else part as well. So let's introduce another variable over here. Let z equals 0 at the moment, and we want it to be mutable, so we will mutate this variable. So if y equals true, then we will use z plus equals x. All right, then we'll return z from here, or else we'll return 0 from here. All right, so it says that the name function add already defined. Okay, we'll use add another. So as you can see, this is what. Now let me check it with the println statement over here. So we'll use the result of add another, and we'll use a result 2 over here, right? So for result 2 we need to consume this add another function. Let's say let result 2 equals add another, and I want to introduce 5 comma true. So let's see how this behaves. Our expected behavior is to return it 5, but let's say let's rename the 0 value to 2. So the expected return of this function should be 7, right? So we are passing 5 and we are passing y true. So if y is true, then it should be added, right? So let's save this, open up our terminal, cargo run. So as you can see, add another return 7. So this is how if else work. It's a basic simple if else condition. You must have like encountered it in every programming language, but the only difference is the if here doesn't use parenthesis just like JavaScript or any other language. Some of the language does not require parenthesis. So use if y equals true, then logic is performed and this will return. Now note that I have used a previous concept over here, that I didn't use any return statement over here, right? So this is also a perfectly valid return type. And let's understand how loops work. In Rust we will learn about loop and for loop. For now, I mean, we will definitely cover other things as well in the next chapters, but for now we will learn these two topics only. One is loop keyword and for loops in Rust, right? So let's head over to loop. So to implement a loop, we'll simply use loop keyword and its body, right? So whatever we write inside this will be like, and this will iterate infinitely. So this keyword loop will create an infinite loop. All right, so we need to break it. Now let's see how do we break it. Okay, so let's introduce a print line over here that we want to keep printing this to a terminal. So let's say we want to create a counter over here. Counter is, we need a variable counter. So let's create a counter. Now this counter will be updated, right? Because it will be inside loop, so we have to make it mute. All right, and we will perform a logic over here. Counter plus equals 1. Now we don't want it to run infinitely, so we will introduce a break condition using if else, right? So if counter equals 9, we will use break. So as I can see, there is something wrong with this. So can you imagine what is this? But I don't want to correct it right now. I want you to show how this loop will work, right? So why do we call this infinite loop? So there is a problem with this loop, but let me just show you. Save this, open a terminal, and cargo run. You see this? That's why this loop is really like potentially a bomb kind of thing. So ideally we have to introduce breaks in loops as well, right? Because otherwise it will run like infinitely. So for now, let's hit command control C and exit this terminal. So let me just show you what is the problem over here. The problem is, can you guys guess? The problem here is I have defined this counter inside a loop. So every time the counter will be 0, it will never be 9, right? So I need to move this out. So now that the counter is initialized only once, now this program will work. All right, let's open terminal, cargo run. You see 0 to 8, and as soon as 9 hits, it breaks out of the loop. So always remember, using this loop we have to like double check and manually implement this break condition over here. Now there we have another loop over here called for loop. So that has a limitation that how many time it will run. So let's introduce that as well. So let's say for and x in 0. So this is the syntax for loop in Rust. You see, for x in 0 to 10. Now 0 to 10 is the lower and upper limit for which this loop will run. So 0 is included and 10 is excluded. So it will run 0 to 9, right? Just like any other for loop in other programming language. So but the good thing is we don't have to implement break condition over here until we want something that we want to break. So counter is, we simply use counter. All right, we will only print counter over here. Now this variable x is unused, so we can also use x over here. Let's use x over here. Now as you guys know, value of x will be first 0, then 1, then 2, then 12, like 9. So it will iterate 10 times, and the expected value of x will be 0, 1, 2, 3, so on as to 10, right? Let's run this code. So as you can see, the first one ended up till 8, the another one started from 0 to 9. So yeah, so these are the loops, guys. So we have like we have also while and do while kind of loop, but for now we will learn only two loops. One is the loop keyword that creates an infinite loop, and you have to manually create a break in that. And secondly, another one is like index based, right? So we have a limitation over here, this upper bound and lower bound from which to which the code will run. So every language has for loops, right? And this loop over here, this will create an infinite loop over here. Now let's move on to the next point on the table. We have shadowing. So for shadowing, we will let's move again to this mutable immutable part, right? So as you know, to make a variable mutable, we have to use mute keyword. But what if I tell you that you can make a variable mutable without using mute keyword as well? Isn't that fascinating? So that's where shadowing comes into play. Let me just show you. So as you can see over here, you have a variable mute a, right? You have make it mutable because you want to update it, right? So let me just show you how you can update a variable without using mute keyword. So let me just create another variable over here. Let's say let j. All right, let's j is equal to 0. Now I want to mutate this to j equals 2. So what do I do is I will again use a let statement. So I will reuse the variable. This way the j, I don't have to define mute as well. Now this is called shadowing. So now this new variable will shadow this previous variable, right? I have reused the variable and I can still print j over here, right? So as you can see, earlier j was 0. Now that it is, you can see it is like slightly faded, right? Because it is not used, we have used this now. Now this j has shadowed this, right? So this is how you update a variable without using mute keyword. This is called shadowing. And this variable that shadowed this value, it implemented a variable shadowing concept, right? Let me just run it for you guys. So as you can see, few warnings are here that we can definitely omit out right now. Before value 2, after value 2, updated j value after shadowing is 2, right? So let me exit this. So as you can see, earlier j was 0, now it's 2. So yeah, so these are pretty much all the topics that we have covered today. These are the basic topics, and I would highly recommend you to perform exercises on these topics, right? Go to Rustlinks or any other website of your choice, and please perform exercises as well. Let me just tell you one more thing. On the next chapter, we will cover like important topics in Rust, like ownership and borrowing rules. Alright, so that's it for today's video, and we'll cover ownership and borrowing rules in the next chapter. Till then, keep grinding, stay happy, and like, share, and subscribe.